So welcome to this class. As promised in the previous class, we said that we are going to solve a problem involving both the product rule and the sum rule. So let's take the problem and discuss the solution. So the problem says that each user on a computer system has a password which is 6 to 8 characters long, where each character is an uppercase letter or a digit. So each password, so other conditions given, each password must contain at least one digit. So the question is, how many possible passwords are there or are possible? So let's read the problem and understand what it means. So each user on a computer system has a password. So let's start highlighting some of the key things in the problem. And then the password is 6 to 8 characters long. And then each character is either an uppercase letter or a digit. But then one of the fundamental elements of the problem is that apart from each character being either a letter or a digit, then every password must have at least one digit. So this is also very key. Must have at least one digit. So the question is, how many possible passwords are possible, or how many possible passwords are there? So when we say 6 to 8 characters, then it means that then the length of the password can either be 6 or 7 or 8. So that's the starting point. So solution. So we'll say, let P be the total number of possible passwords and let P sub 6, P sub 7, and P sub 8 be the passwords with length 6, 7, and 8 characters respectively. And so therefore by sum rule, P, the total number of passwords will be given by P6 plus P7 and then plus P8. So that's what we have. But finding each of these P6, P7, and P8 is not a very direct thing to have as give as the conditions specified in the question. So to find P6 or P7 or P8 is not very direct. It's not very direct to find the values of the P6, P7, and P8. So, for instance, to find, actually just now say, so to find, what for example, just let's pick P6 first and explain how we can get P6. So to find P6, it is easier to find the number of strings of uppercase letters and digits of the string and digits that are not of strings, digits that are digits that are 6 character long, including those with no digits, and subtract from this the number of strings with no digits. So this is what I mean. So I want to explain how to find P6. So P6 means that my password will have 6 characters. So I want to draw 1, 2, 3, 4, 5, 6. And then let me have another one here. I have 1, 2, 3, 4. So 1, 2, 3, 4, 5, 6. And then I have 1, 2, 3, 4, 5, 6. So remember, this is what we have. We know that we have 26 letters and we have 10 digits. So we must know this one. So you mean that the total number of characters, digits plus letters, we have 26 plus 10, which is that 6 characters in total. So in this first box, if I assume that I'll pick this box here, this first character in my password can either be a digit or a letter, then I have 36 possibilities. This second one, if I have the same assumption, then I have 36 possibilities. These 36 possibilities, 36, 36, 36. And then this is how another person can pick the same thing. I assume that I want to use letters, so I can have 26 choices, 26 choices, 26 choices, 26 choices, 26 choices, 26 choices. Another one will say, let me pick only digits, 10 choices, 10 choices, 10 choices, 10 choices, 10 choices, 10 choices. Now, let me just pick a random example. Like when I say I'm picking the first option, I can have a possibility of saying, let me have this one as letter A, because it's one of the letters. I can have a possibility of taking this one to be X. There's a possibility of me getting this one, say letter T. There's a possibility of having this letter U, possibility of having this letter B, possibility of having Z. Because it's one of those 6 options. Or someone can say, I have A, I have 1, 2, X, Y, Z. There are many, many possibilities. But you see, this is a possibility of getting if you have the 6 options. But according to the question, that password AXTUBZ is not required because we have been given the condition that each password must contain at least 1 digit. So though with this 6 options for each, this one is can be a possibility, but from the condition given, we don't want such things. Though this one is fine, because at least we can see a digit. For this one here, I can have A, I can have X, W, X, B, T. All these ones here, there is no possibility for me getting any digit in any of the boxes. So actually, this is actually out, because all the password that can be formed, none of the password will have a digit. So actually that one will not be correct. For this other one, an example is like have 1, 2, 9, 0, 1, 8. This is fine, because when you say at least, we mean we need to see 1 digit or all the digits. So this is perfect. So any that you'll get from this combination will be just perfect. But here, we'll have those which will be correct, we'll have those which will be wrong. So then how do we know which passwords will actually have all the conditions specified in the problem? Let's pick a scenario like on a day where students are taking rice and beans. There are those students who don't like beans. They only prefer rice. So what happens when they are given the mixture rice and beans is that they'll get the mixture and then take out all the beans from the mixture and then remain with rice. So the rice is what they really wanted. They didn't want beans. So that's what we are going to do here in the same problem. Well, this one is giving us a possibility of having the correct thing and the wrong thing at the same time, though we only want the correct thing. And this second one gives us all the wrong things. So therefore, we'll pick what we have here in this, if we call this 1, we subtract what we have in 2, and then we are sure that what we'll have will always be the perfect one, because all these are wrong. So these are within this bigger set of passwords. So therefore, and these are how many possibilities from product will be the same as 36 power 6. This will be the same as 26 power 6. If you are to do this one, it will be 10 power 6. So therefore, when I say 1 minus 2, this set 1 minus set 2, then I'll remain with only those ones which satisfy the property that is required in the question. So therefore, for P6, the total number will be 36 raised power 6 minus 26 raised power 6. And when you work out this one, you get 18, 67, 8, 6, 6, 5, 6, 0. Get a number to that. Similarly, in the same reasoning, for P7 will have that 6 power 7 minus 26 power 7. That one will give us 7332 353 920. And for those with 8 characters, P8 will be 36 power 7 minus 26 power 8 minus 26 power 8. This will give us 2612282 842 and then 880. So therefore, the total number of passwords will be P6 plus P7 plus P8. And when you work out that one, you get roughly 26, 84, 4, 83, 063, 360 possible passwords. So that's the answer to that given problem. Thank you.